All right, welcome to this class. Welcome to the class. So I'll be explaining this some of these questions to you. The solution before we move to another topic. It's just a marathon class for those of you writing SSCE. All right. The first question here is A, B, and C are points on the circumference of a circle with center O. Find the value of x. Okay, so first you need to understand that one of the theorems of circle geometry is that angle on the semicircle is a right angle. That is, the semicircle is created by line AC. Look at it, line AC. Right now, the angles built on that semicircle is a right angle. So you already have a triangle that way. You have 90 here. So when you add up x plus 90 degrees plus 55 is equal to 180 degrees. That's sum of angle in a triangle. That's x plus 145 is equal to 180. That will be x is equal to 180, minus 145. That will give us 180 minus 145, that's 35 degrees. So that will be the answer to this particular question, right? And then we move on to the next question on page 2. The P, Q, and R are points on the circumference of the circle with center O. Alright, said work out the angles, work out the angle Y. The side of the angle Y is what we are looking for. And it said give reason for your answer. Okay, so angle Y is actually direct. It's a very simple question. Remember that one of the theorem of circle geometry is also states that angle at the center is twice angle of the circumference. So if you look at this now, when we join P and R together, it means that this angle Y is 2 times angle Q. That is, Y is equal to 2 times angle PQR, and that's 2 times 50, and that's equal to 100 degrees. Okay, so the reason for this is angle at the center is 2 times angle on the circumference. We move on to the next question here. It said AB is a tangent to the circle. Write down the value of x. Alright, so now I think this is trying to explain each theorem to you. Now, one of the theorems in circle geometry is also stating that angle on the tangents, angle in alternate segments, they are equal. Angles in alternate segments are equal. And that is, look at this now. You have a tangent AB, right? Then we also have a segment that was formed by this chord on that tangent. So whatever angle is formed on this tangent, just like as I'm drawing like this, look at the first one, look at the other one. Whatever angle formed on that segment will be equal to that same angle. Do you understand? That's why x here will be equal to 43. X equals 43. Angle in alternate segments. If you look at it from this side, this angle will be equal to this angle, because this line that you are seeing here, the angle built on it is this way and this way as well. Alright, so x is equal to 43 degrees as well. We move on to the next question. Okay, it said work out the size of angle Y in this diagram. Alright, so working out the size of angle Y in this diagram is quite easy. Look at this line CO. Look at this triangle. This point, this is a radius. This is a radius, right? So it means that here would be 90, because one of the theorems of geometry states that a line drawn from the center of the circle touching the tangent is perpendicular to the tangent or is a right angle. That's why we have this place that I marked as a right angle. So we already have that part. And then this is also a radius. This is a radius. It means this angle and this angle, they will be equal. Here is 25. This part will also be 25, right? So the sum of these two 25 will give you this external part. 25 plus 25, that's 50. So you now have triangle OED. So treating triangle OED, you have y plus 50 plus 90. That right angle will give us 180. So y is equal to 180 minus 90 plus 50 is 140. That will give us 40 degrees, right? I believe you understand the explanation I gave there. As I proceed to the next question, said the diagram shows a circle center O. All right. Work out the size of angle X. Okay, so the size of angle X here. Okay, and then angle Y too. We are also working out the size of angle X and Y. So when I join these two parts together, it's easy for me to get angle X because angle at the center is 2 times angle on the circumference, right? So I already have this angle X to be X is equal to 2 times 75. And 2 times 75 is 150. So here is 150. That's angle X. Now, I know that this is a radius. This is another radius, forming an isosceles triangle. So these base angles will be equal. So since I've gotten my base angles, then I can say that the sum of these two base angles, which is, let's say U. Here will be U. The other side will be U. So U plus 150 will be equal to 180. Sum of angle in that triangle. That's 2U is equals to 180. 2U plus 150 is equals to 180. Okay, so when you subtract 150 from 180, you'll be having 30, right? So 2U is equal to 30, then U equals 15. So here is 15. Here also is 15, right? So we have a whole triangle. Now look at the triangle here. Let me draw it out for you to see. We have, here is Y and that 15 plus 15. Here is 18 plus that 15 because it's the whole angle I brought out. That's angle B, angle C, and angle A I brought out. Then this other part is 75. So when I add up together, 75 plus Y plus 15 plus 18 plus 15 must be equal to 180. Sum of angle in a triangle. Then I'll be able to sum up from there, subtract my answer from 180, I will get my answer for Y. It's as simple as that. Alright, don't forget this is a revision. I'm not teaching you. Just go back and study it. By now you should be prepared for your exam anyways. Alright, look at this question. It said work out the size of angle BCD. Work out the size of angle BCD. Okay, so what's BCD? BCD. We're looking for this particular angle here. Okay. And what else do they ask us to look for again? They must ask us to look for something else. You can't just ask us to look for BCD. Sorry about that. Okay, so it said BCD and ABC. So if you are looking for BCD in a cyclic quadrilateral, one of the theorems in circle geometry, these two angles XY, WZ, the sum of those two angles are actually, they are equal. That is, x plus y is equal to 180. The sum of them must give you 180. The other one again, w plus z, must give you 180. Now, look at it. It means that this is the opposite angle to A, which means that 72 plus BCD will give us 180. So BCD plus 72 is 180. Obviously, you know how to get your BCD. Just take away 72 from 180, you get BCD. And then again, one shortcut I need you to know for objective is, because you're also going to do the same, you're looking for ABC. ABC. This angle here is equal to this angle. That's the shortcut, because if you say that sum of angle on a straight line, that's 180 minus 125, you get this part. Now, opposite angle of a cyclic quadrilateral, 180 minus 125, you will still, minus whatever you get here, you will still get this value. So that's why ABC is equals to ADE. Know this and know peace. Okay. And I'll stop my journey here on this question. If you have any more questions privately, probably any of those questions seems kind of complex to you, you can chat me privately and I'll explain them to you. Alright, so this final question I said, work out the size of angle X. Of angle X, alright. Okay, so this triangle ABC is an isosceles triangle, meaning that this angle and this angle will be equal. And you know that I mentioned earlier that one of the theorems states that angles in alternate segments are equal. Look at it. There is a segment, there is a tangent here, and then there is a chord touching that tangent, which means that this angle here will be equal to this one here. That's 52. And because it is an isosceles triangle, here automatically becomes 52 as well. Alright, so I've gotten 52. I've gotten 52. We are looking for the size of angle X. When we solve the sum of angle in triangle ABC, that's 52 plus 52 plus angle ACB will give us 180. So that will be ACB is equal to 180 minus 52 plus 52 is 104, right? That will be 76. So here is 76. So since that place is 76, is also equal to this part. Angles in alternate segment. Look at that line. You see it is on this part, and the triangle is built on it, on that particular segment, that line I drew just now. So it means that here also will be 72 alternate angles. Angles in alternate segments are equal. So since we have 72 here already, then we can get the value of X, because this is another tangent again, which means that this particular this angle will be equal to this angle. That's 76, so not 72. So here will be 76 as well, right? Here will be 76. 76, 76. Sum of angle in a triangle. 76 plus 76 plus X. That's in angle. We are dealing with triangle ABP now. That is this triangle here. So when you add up, let me rub off the mistake I did here. Alright, so 76 plus 76 equals 180. That's X rather, plus 76 plus 76 equals 180. 80 degrees. Then x equals 180 minus the sum of those two angles together will give you a final answer. All right, so I think I've been able to explain this well. So follow up for more explanation. It's just a revision class, a crash revision class for your forthcoming examination. Thank you for listening. Thank you for watching. If this was helpful, click the like button and subscribe, and also share it.